أهلا أستاذ.
كيفك هيكل؟
منيح منيح.
Yeah, can we start, Shabab?
Yes.
Yeah. 2008, this is the last day we are going to solve complex. Next week, we solve about 5-6 exercises transformation. Okay. (2008). In the complex plane, refer to a direct orthonormal system, OUV. Consider the points A, B, and C of affixes radical 3 minus I, B radical 3 plus I, and C equal to I. How to show that these 3 points, A, B, and C, are on the same circle? How to prove that A, B, and C are on the same circle of center O?
Modulus.
Yes, boys. Modulus of what?
OA, OB, and OC.
Modulus of A, modulus of
And
B, modulus of C. So here we say OA equal modulus of A equal radical 3 plus 1 equals 2. OB equal modulus of B equal radical 3 plus 1 equal 2. And OC equal modulus of C equal radical 4 equals 2. It means that OA equal OB equal OC equal 2. OA equal OB equal OC equal 2 means that A, B, and C belong to the same circle of center O and radius 2. Any questions about part 1?
No.
Because it is done, did you finish writing?
Yes.
Part 2. Write C minus B over A minus B in the algebraic and the exponential form. هيدا simple. In the algebraic and its exponential form. So C minus B over A minus B equal 2I minus radical 3 minus I over radical 3 minus I minus radical 3 minus I minus radical 3 plus radical 3. So minus radical 3 plus 2I over minus 2I. بالtest you can directly use your calculator and find the result. Times I times I. We get minus I radical 3 minus 1 over 2 equal minus half minus I radical 3 over 2. This is the algebraic form. Yes?
لما نعمل times I كان ما بصير opposite sign لل I.
بلا كان minus 2I. I can multiply by 2I over 2I. You change the sign before the imaginary part.
Yes.
You can multiply by 2I. So the modulus of C minus B over A minus B equals radical 1 over 4 plus 3 over 4 equal 1. By using your calculator, the argument بتاعتي minus 2 pi over 3 or 4 pi over 3 the same. So the exponential form is e minus 2 pi over 3i. Because it is done? Yes?
It says that 4 pi over 3 نفس minus 2 pi over 3.
هذا السيركل هيك.
لأنه بالثird quadrant.
هي بالثيرد كوادرانت هي 4 pi over 3 here. 4 pi over 3. If we read it from the positive 4 pi over 3 from here to here. If we take the clockwise or the negative direction, it will be minus 2 pi over 3. It is the same.
Thanks.
أستاذ هيدا ما فينا نحط
لا.
دغري على الكالكوليتر.
Yes, you can
أحسن
directly.
على الكالكوليتر.
Yes. Part 3. Let M be a point other than O. M a point other than O of fx z equal x plus iy. In the plane P, x and y are real numbers. Let z equal z minus b over z. Determine the set E of points M such that modulus of z equal 1. How to determine the set of E if the modulus of z equal 1? Yes, boys. How to find the set of points if modulus of z equal 1? So, solution of 3. Modulus of z equals 1. Z is z minus b over z. Modulus of z minus b over z equals 1. So, z minus b, modulus of z minus b, equal modulus of z. Modulus of z minus b equal modulus of z. So, zm minus zb equal modulus of zm. It means that bm equals om. The m belongs to the perpendicular bisector of AB, of not AB, of OB. Part B. How to verify that A and C belongs to E? How to prove that A and C belongs to E? إيه يا شباب كيف برهن ال A وال C belongs to E؟ How to prove that A belongs to the perpendicular bisector of OB? هلا في عنا ب two methods. Either I replace Z, this small z, by ZA first time, ZC next time. So I have E here, modulus of Z equal 1. I put instead of Z, ZA and ZC. To prove that A belongs to E. A here modulus of Z, big Z equal 1. يعني modulus of, I need to prove A belongs to this set, ZA minus ZB over ZA, modulus of ZA. So radical 3 minus I minus radical 3 minus I over radical 3 minus I in modulus. See, modulus of minus 2I over radical 3 minus I. The modulus of the numerator is 2, modulus of the denominator is 2, equal 1. So A belongs to E. Now to prove C belongs to E, the same, instead of Z, I put ZC. C belongs to E. So modulus of ZC minus ZB over ZC. 2I minus radical 3 minus I over 2I. So modulus of minus radical 3 minus I over modulus of 2I. Radical 3 plus 1 is 2 over 2 equal 1. So C belongs to E. The last part in this exercise, determine the set F of points M such that Z is pure imaginary. Determine the set F. In which case يكون complex number pure imaginary.
So يعني هذا ناخد imaginary part of that I radical 3 over 2. لا هي C minus B.
The imaginary part of Z, Z كبير, capital Z.
One real part is 0. ناخد real equals to 0.
So I have to find, I have two methods. First method, I put instead of Z equal X plus IY here. Then I take the real part equal to 0. First method, I put instead of Z X plus IY, here can it Z minus B. So Z minus in X plus IY minus radical 3 minus I over X plus IY over Z. Capital Z, here Z minus B, small z minus b over small z. Z is x plus iy minus zb is minus radical 3 minus I over x plus iy multiplying by the conjugate. Expand x times x, x squared. بالإكزام انتبهوا بالمultiplication minus ixy plus ixy minus I squared y squared بتصير plus y squared minus radical 3x plus I radical 3y minus ix minus y. So the real part, x squared plus y squared minus radical 3x minus y over x squared plus y squared. The imaginary part is radical 3y minus x over x squared plus y squared.
هلا ناخد real part 0.
Z is pure imaginary. Real Z equal to 0. Then x squared plus y squared minus radical 3x minus y equal to 0. تذكر امبارح كيف كنا بنلاقي السنتر والراديوس؟
Yes.
Center, I divide the coefficient of x by -2. It becomes radical 3 over 2. The coefficient of y by -2. M belongs to a circle of center. Radical 3 over 2. 2 half. Radius equal radical a squared. هيدا a وهيدا b. Minus c. تعطينا 1. So M belongs to a circle of center. Distinct لازم نزيد هون distinct from O أو different from O. Distinct from O.
ليش أستاذ؟
إذا هون قلنا بالquestion let M be a point other than O. Okay.
Yes.
Or I can solve it by another method. For a complex number to be a pure imaginary, its argument is either pi over 2 or minus pi over 2. Yes or no? For a complex number to be pure imaginary, its argument is pi over 2. To be real, its argument is either 0 or pi. So I put argument of z minus b over z equal plus or minus pi over 2. Argument of zm minus zb over zm equal plus or minus pi over 2. So the argument is the angle OMBM. OMBM equal minus pi over 2 plus or minus pi over 2. So M belongs to a circle of diameter OB deprived from O and B.
هي كمان ليش نكتب أستاذ؟
Yes?
ضروري نكتب deprived هيك الشيء.
Deprived distinct, yes. You have to say it or you lose 1/4.
أستاذ بس ليه عم نكتب هيك يعني؟ M belong to circular diameter O and B.
You know that if you have from grade 8 and 9, if you have a diameter AB or OB, any point on the circle except at O and B, the angle O and B how much?
180. 90.
90. Any point on the circle بتكون 90 بس إذا كانت الام على الأو ما بصير الانجل 90 أو الام at B, the angle will be not 90.
Yes.
This is why we say it is deprived from O and B.
يعني بده يصير M هاي لمحل على السيركل بدل محل O and T.
Yes. Okay, we solve another exercise. Did you get tired?
شوي.
خلاص أستاذ أصلا بنعرف الدرس.
أستاذ أصلا بعد هيدا عن
طيب اوكي.
شغلي.
طيب اوكي. Please أنا بعت لكم شي 5-6 problems من هذا الدرس solved. You can see them.
اوكي.
Okay? يلا.
صعبين شيء.
Have a nice weekend.
بس
لا.
يلا باي أستاذ.
You can see them. They are solved from the
Oh.
sessions. You can solve them. شي 5 problems. Okay, يلا باي باي.
باي باي أستاذ.
استاذ عمود submit.
submit
ايه البي دي اف؟
لا which one how
هيدا.
I have submitted them. I have submitted 5-6 exercises. You will check them. PDF, yes.
اوكي استاذ، يلا باي.
Yeah, bye. Bye.